Hey, everyone, and thank you for joining us for another episode of the Bender Podcast. We are very happy to be going live today. And I thought to mix it up a little bit with the live, when we go live, I wanted to do it with my user group, the SolidWorks user group, the Southern Kentucky user group. You can kind of take a look at them, wave everybody, say hi.
Hello, hello.
Hello, guys.
So one of the things that we've added into our user group and into our workforce here, we've added some new bodies, Gavin and Cody, who you just saw Gavin on screen. And they hadn't used sheet metal like a lot of people. They didn't have a lot of experience in it. And when we're doing sheet metal questions and stuff, a lot of that comes up to where you've been using SolidWorks for a long time, but you don't necessarily use those sheet metal functions. And in those sheet metal functions, one of the mistakes that most people make is they want to go in and they'll start drawing those sheet metal parts and they'll draw them as a 3D model. And you can absolutely do that. And if you listen to one of my podcast episodes, you've seen how we converted from sheet metal and then we took that part and made a sheet metal part out of it. But we want to do that. What we're going to do is if you're needing to use sheet metal, whether you're going to a job that's using sheet metal or you're dealing with a vendor who's using sheet metal, we're going to teach you how to do it correctly. Now, the name of this episode is the 10 core commands of sheet metal in 10 minutes. I was fortunate enough to have a CEO that I worked with years ago, and she always would tell me, give me what I need to know in 10 minutes and less. Give me the 30,000 view look at it, and I can take it from there. And a lot of times, all of you already know how to use SolidWorks. You're getting into using the sheet metal tools. You may not know what they are. And so that's what I want to do today. I want to help you become the expert that I know you can be. And we're going to go through these 10 steps. And it's not everything you'll use, but it'll give you a good workflow to start creating sheet metal parts. So wait till the very end. So any questions that you have, please wait till the very end, and then we'll answer them. If you're joining us online, welcome. Cody is running the board over here. So anything that you had, if you wanted a question or whatever, please put it in the comments. And let's dive into it. Now, what we're going to talk about is all about that base flange. The core of any sheet metal part starts with the base flange, and I'm going to start by drawing a sheet metal part. It's just a rectangle. So I'm going to draw this rectangle, and this is going to be like where all of my part flattens out to be. I'm just going to put some just typical dimensions into it, nothing fancy. And then we're going to then use the base flange command. And once we do that, then we're going to give it a material thickness, and we're going to give it what our K factor is. And that's how you do a base flange. Now, if you want to get a little bit more intense and you know that your flattest surface is going to have more texture to it, like it's going to have, in this case, let's just add a radius into it so that we can have more than just a flat rectangle part. So what I'm going to do is I'm going to sketch it out here real quick, and I'm just going to add this radius in there so that I can start with my base flange, and I can already have that as part of my flattest surface. And the process doesn't change here. What's going to happen is, as we're doing that, we're going to be able to then, once we apply the base flange to it. Okay, after you do that base flange, what you have at that point is you can go in and you can start adding other things to it. The base flange, the best way to explain that is, when we were all kids in school, we created different things out of paper, whether it was a paper football or, some of us was super talented and we were creating, starships out of it or, origami animals and stuff. But everything in the end, when you're making those characters or those things out of paper, they have to unfold. And once they unfold, they go into their flattest surface. And that's where you're going to start with the base flange. So that's where we come up with that all about the base flange. That's where we're getting that information from. We're going to create that base flange, and we're going to move forward. Now, you can get as fancy with this as you want to. If you know what the flat pattern is going to look like and you want to go on and do that, you can do that. If you just want to keep it simple and you want to go back and add that later on with other sketches, you can do that. Now, the next thing we're going to get into, Cody, is we're going to be living on the edge here. And this is another one of the features that I use in sheet metal all the time. It's the edge flange feature. I'm going to go on and draw us a base flange again. And once I get this base flange in, I'm going through the functions and drawing this so that you can see my workflow on how I'm doing that. So when you're trying to create it yourself, if you just want to go back in the timeline and come back to one of these commands, I'm not leaving out how to get the base flange and the stuff So as we go forward, some of the stuff we're talking about, it'll just stack. So now that I've got my base flange created, I'm going to go in and I'm going to add custom flanges to my part. I'm just using the edge flange and I'm just picking around. And the reason that I'm using the edge flange and I'm picking all the way around is so that I can get my corners really nice. So when I go to unfold this later on or send it to processing to either be outsourced or made on a factory floor, that I've got really nice corners. Now I'm going to accept that, and when I'm done, I'll flatten it out here for you, and I'll show you what I'm talking about those corners. Now, when you see that it's flattened now I can send this out for any type of NC, whether I'm doing laser or whether I'm doing punch press. And this basically is just a good starting point. I didn't do anything really crazy here. I just added on some typical flanges going all the way around the part, and I added one edge flange into my feature tree. And the reason I did that is so when you've seen that flat pattern and it laid flat completely out, then that way we can go back in when we're sending that out in a DXF file, and I'll get into that later down in the features. When we send that out in a DXF file, that you can then see all of that, and I'll show you some ways of how we can even manipulate that. So moving on down to step 3, we're going to talk about let's hem it. Now in this demonstration, I'm going to show you how to create a feature called hem. And when we do this, the reason that you would create a hem in the manufacturing environment is you've got a surface that is going to be a sharp edge that could, cut a potential customer, cut somebody on the floor. And you're just going to kind of lay that over. When you're using brake tooling, it just kind of flattens that on over. So as I'm drawing the hem, you can see how I'm just flattening it out there. I'm going to take that, enter all of my information in there for my hem. Basically, I'm just going to tell it how long that hem is. I'm going to let it flatten out, and you can see there, it just created me a nice flat edge. Now, when we're talking about the hem, this is another tool that you'll probably use as we're going through there and we're stacking. Step 1, we created the base flange, and that gave us the flattest surface that we're working with. Then we went on to step 2. This is typically where you're going to create your edge flanges. This is where you're going to start forming your part. Now, hems are things that'll be added. I like to call it edge flange and friends, because what will happen is as you're building on with your edge flanges, then you get information like that to where I need a treatment for a corner that I need a hem on. So as we're going down through there, the edge flange is going to be getting a lot of friends that you can use as you're building a sheet metal part. So now we're ready to go to step 4. Now I call this jog on, and the reason I call it jog on is I never use jog. It is a feature that is in SolidWorks. Typically I will use another feature for this later, but I'm just going to quickly show you how to use the jog feature inside of SolidWorks. And we're just going to create a base flange here real quick. And after that base flange is created, then I'm going to go through how to create the jog. So I've added the material to it. I've given it my K factor just like I did all the previous parts to this. And now I'm going to start working on creating me a jog. Now what I'm going to do here is I know that a jog is normally a bend that is used if it's going to go under something. It's basically just a step up where you have like one bend that comes up and then it bends over. So I'm just going to sketch that really quick, and I'm going to give it a dimension for what I want the end result to be. So I want that first flange on the top, the dimension that I entered of 20 millimeters. And then when I go in and I enter my next one, once I get everything selected, when it pops up there, that's the second I enter, whether that's going to be 10 millimeters, 5 millimeters, whatever I want that to be. And that's pretty much a jog. I do not use this in a day-to-day function. I've used edge commands. We'll get to sketch to bends later on. These are the different things that I use, but if you just need something to where you're needing this to slide in like a tray, or something to where you're hooking two parts together, this is a quick, easy way in order to do that, and that's what the jog feature is. But the main reason why I called it jog on is because I pretty much pass up on this one. I don't use it, but you may have an application and a workflow to where you're going to add that into your daily workflow. If you do, that's how you use the jog. If you want more information on that, you can leave that in the comments, or you can, email me directly, and we'll talk more about the jog. Personally, I've not used it in my daily workflow, but if you do, I wish you the best with that. Now, This is one of my favorite ones I use, and I'm going to give Cody credit on this one. When we were starting to talk about different ways when we were training sheet metal, we went into where we were doing what we called, I'm calling this straight out of sketch and into bend. We were using a sketch to bend, and where this comes in and where it's very useful is when you're using sketch to bend. Let's say that you've got we'll just use the instance of a vendor. You've got a vendor that sent you a flat pattern in the drawing, but the DXF file that they've sent you is in the flat form. So what you're going to have to do, and I'm going to sketch this out for you as I'm talking here, I'm going to sketch out just a basic flat pattern, what you might get from an outsourcer, or you might get from legacy data that you've got in your own vault. But when you get this information, you don't have to go back and recreate the part because you've already got the flat pattern. And what the sketch to bend allows you to do is it takes that DXF that you've got, that I'm creating here, and it allows you to apply bend lines to that DXF or to that flat pattern, which it's basically going to be our base flange. So it's just going to be our base flange, but it'll be folded out. So once I get this completely drawn out, I'm just going in here and I'm just using some abilities. I'm just going to create a box like we did in one of the other demonstrations with the edge flange, just to show you how you would get that from a DXF part. Now that I've got that base flange created and I've got that information in there, I can go and I can start putting my bend lines in there. So I'm just going to really quick create a sketch, and I'm going to start sketching in my bend lines for where I'm going to put all of my information. So on this one, I'm just giving it that first bend there. Then I'm going to come over to my position 2. I'm going to do another sketch line for it. And then I'm going to do a third, so on and so forth. So however many sketches that you need for your part, you put them in here. Now, where this comes in, and the reason I'm able to do this with one sketch is because they're all at 90 degrees. If I had, position 1 and position 2 was at 90 degrees, but position 3 and position 4 was at a different angle, then I would have to do 2 sketches because it's only going to process that with 90 degrees, or it can do 90, it can do different angles at 45, but if they're different, then you have to do multiple sketches for each instance that is different. So now I've got all this information I put in here, put a couple equations, so if I wanted to come back and change it, that I could get that information to flow pretty quickly. So now that I've got that in there, I'm able to go use my sketch to bend command. And when I do this, what you're going to see real quickly is it's going to pick those bend lines. And I'm trying to get caught up with where I'm drawing here. I apologize. Okay, I got to pick my surface, and it automatically sees those bend lines, and then it folds up. So then that is your finished product right there. So you can take that legacy data from whether you've got a DXF that a supplier has sent you, or if you've got that information that's in your vault to where you had old 2D drawings before you went to 3D, then that's where you would use that. And this is something you'll use all the time. Now, when I was talking about the jog on, that is an instance to where I would use sketch to bend instead of jog on. That's where I use in my daily workflow. If I've got to add a jog to where I've got maybe a tab that I'm putting into the middle of a part that I'm going to do to where I'm going to have a step up to where some people use a jog, I just draw that out in my base flange, and then I will use the sketch bend to do that. Now, this is one that I love the name of it. We're going to do step 6, and we're going to go into what I like to call the knockout round. And what this is if you're dealing in sheet metal and you're having to do parts to where they've got, any type of formed tooling, you're going to need to have in your design library, you're going to need to create these formed parts. So what I'm going to do, I have to have somewhere to place this part into. So this is one instance where I'm going to just actually 3D model up a surface so that I can put my form tool into it. So all I'm doing is I'm just taking one of my thinnest sheets of metal, and I'm going to draw it up real quick. And once I get that plate there, now I can start adding a form tool to it. And I'm just going to draw, the reason I called it the knockout is that's one thing we use around here all the time is a knockout tool, to where we'll do a 50 knockout, and we'll have that where that you can go in and knock that part out down the line if you need to run like electrical or something through that. So I do my sketch, and I create an extrusion here. And I'm going to go on and give it a little bit of a taper just so you can visually see that. And I also want it to, when I'm dealing with forming tools, I want it to be able to cut. When I'm putting it in my part, I want to have that profile on the front, but I'm also, when I look at the back side of it, I'm also going to have an indentation there to where that form tool will push through. So that way, when I'm sending out DXFs to my NC programming, I have that in that 2D flat DXF, depending upon what surface that it picks, I've still got that round on there. And what I'm doing here is I'm going to go and select what I'm going to cut away from, and then what I'm going to add the extrusion to. So the blue and the yellow is what's going to be added, and then the blue is where it's going to be added onto your part. So now I need to add this to my design library. And the reason I want to do this is that's why I'm creating this form tool. I'm going to create it and I'm going to save it out as a form tool, and I'm going to save it into my design library. And what this is going to allow me to do is not only for me, but for my team, anytime they go in and they need to use a form tool, they can go to the design library and they can use this information to bring that in, so they're not having to draw that knockout every single time. But all I'm doing right now is I'm just giving it a name and I'm saving it in the design library, making it something that I can recognize and that my team can recognize, so when they're using it, they'll know how to use it. And it's saved. Now I'm going to go and I'm just going to create a part really quick here, and I'm going to add some knockouts to that part. So let's just say that you had just some type of panel and you wanted to create these pass-throughs for them. So I'm going to go through some of the things that we've done. I've just created my base flange, which was one of the steps that we talked to. Now I'm going to use the edge flange to kind of give it some edge flanges going around. Going to keep it real simple here. I'm not going to get into any complex geometry at this point. I'm just adding some flanges to get me like some type of a side panel. Now that I've got those in there, now I can go to my design library, and now I need to add my knockout in there. So from that, I'm going to go to my form tools. I'm going to go exactly where I saved it. I'm going to see it in my list over here, and I'm just going to drag it out just like I would a file into like Windows Explorer or something. But I found it. I'm going to drag it out and I'm going to place it. Now what it did right there is it went on and it put my knockout on there, and I accepted it. Now I'm going to turn it around a little bit because there's going to be instances to where when you drop that in, I don't necessarily want that form tool to be going different than the bends. My bends are going up, so I want my form tool to go up. So if that's the case and it drops in the wrong location, all I've got to do is flip that. And then what it'll do is after I flip that, it's going to go in there and it's going to be in the right direction. And on the back side, it's also going to show that indentation just like it would out on the shop floor if I was to actually make this with the CNC processing. And I'm going to touch on a thing right here that some of my group asked when we were doing this is we're using a form tool right there. So that is, if you're using CNC punching, more and more we're getting into lasers. So when you get into lasers, you're not necessarily going to have form tooling unless you've got a laser punch combo. And you're going to have things like with that knockout there, you're going to have to create a punch pattern or a cut pattern, excuse me. You're going to create a cut pattern to where you go in there and you cut this knockout out. And you can do the same function with that. You just create another part in your design library, and I called one in sketches, and I saved a laser folder. And then when you go in there, you would just save it out the same way as you did the form tooling. You would just use another form. You would save that out. You would save that out as a sketch, and then it would be in your sketch in your design library. And then the same process you would go through that we just went through with the form tooling. If you need to use any of that, like the knockout for a laser sketch, or if you've got a constant venting pattern that you're using, anything that you're using, that you're sketching, that you're using time after time again, this is where you would create it and put it in your design library. Now, what we're going to do is we're going to go to step 7. And what I'm going to do, this is called bent out of shape. And if you know me, you know how I love using puns for different things. And what I'm doing with this is I've got corners where, let's say I'm dealing with old legacy data, or I get things to where I need to put more than one edge flange. I can't use one edge flange, and I've got multiple edge flanges. Then it's going to create some disjointed corners, and I'm going to have to fix them. So going back through my process, I'm going to do the base flange real quick. Then I'm going to add some edge flanges here. and that's fine. So I've added my edge flanges in, so I'm going to get a nice clean corner for those 3 edge flanges. But when I go in and I add edge flange again, this time on that surface there that doesn't have a flange on it, it's not going to do the corners like it did where when I picked all the way around apart, it's not going to give me a nice clean edge on that. And that's where I have to use the closed corner. And all that's basically going to do is it's going to allow me to enter my information however tight I want those corners to be. And it's going to close them up. Like you can see right there that the flanges are sticking out and you not got a nice clean corner on that. So once I do that, I'm going to go in, I'm going to put this pretty tight because I want it to look like it's welded. Then after I've put my information in for my gapping and everything, I'll pick both corners that I want the closed corner to work on. And when I accept that, now you can see that I've got a really tight closed corner. It's even close. The corners are even tighter than the ones I had done with the other one because I laid that in there. Now when I get my flat pattern and I'm ready to send this out, I've got really good corners on that. So this is another way to where if your NC programmers are having problems to where your corners aren't coming up good and things are happening like that, closed corners is a way that you can go in and manipulate that other than using them inside the edge flange. But in my daily workflow, I'm not really using closed corners anymore. We used the closed corners daily before when we couldn't do edge flanges on all 4 surfaces, and then it had the gapping and everything in. This was years ago. Probably most of you don't even remember that. So now that we got that done, we're going to go on to step 8, and this is called filling the void. And this one is going to be, as I'm drawing it, I'm going to kind of explain what's going on here. In SolidWorks, when you're drawing a sheet metal part, think of it like a sandwich. You've got the things going on in the model view to where you're modeling something, and then you've got the flat pattern. If you want what's going on in the flat pattern to also be seen in the model view, then you have to get those features that you're adding to your model in between that sandwich. It's kind of got to be the peanut butter between the 2 slices of bread. But there are cases to where that you have an instance to where you got a machine, forming tool, or a corner former, and you need it to do a special type of edge. And you don't necessarily want to show it. You can go back and you can show it in the 3D view if you want to. There's ways to do that, but that's not what we're talking about right now. We're talking about how do we manipulate this flat pattern so that we can get those treated edges in there so that when we're doing that NC file and we're taking it out to the machine, we get the corner that we want. Now, one thing about SolidWorks is always let SolidWorks work for you. If you're not familiar with sheet metal, but you're familiar with SolidWorks, you know you need to create a configuration manually when you're doing something. In SolidWorks, if you just bring the flat pattern into a drawing, you don't even have to save the drawing. You just bring that flat pattern into the drawing, it will automatically create you a configuration inside of SolidWorks of the flat pattern. So always remember, don't go and create the configuration for the flat pattern yourself. Let SolidWorks do the heavy lifting for you there. But what I need to do is, in order for my flat pattern to be correct so that I can form this in the machine properly, I'm basically going to have to square up those corners and then put a chamfer on it of whatever that I'm going to need that chamfer to be to get in the machine. In this case, it's going to be around 18. So as I draw this in, I'm drawing it in just like you would draw any other time when you're using 3D tools. I'm just going to sketch in that corner real quick, and then I'm going to do an extrusion on that. One good practice that I add into my workflow is I always try to give any type of sketching or anything. I try to let other users know what's going on by renaming the sketches. But when I've done this extrusion now on that sketch, you can see it's closed in that corner. And that's exactly what we were looking for. Now I need to get that chamfer on there. So I just go in, I use my chamfer command as normal. And remember how we was talking about that sandwich? Okay. When we go back and we look at the tree, now my flat pattern looks absolutely the way I need it. I can send it straight out for tooling. But now my peanut butter isn't between the 2 slices of bread. So what does that mean for me? What that means for me is I've got a flat pattern that I can use, but it's not going to necessarily match the 3D view. If you need it to match the 3D view, if you need it to go in there and you need it to show that, now is when you go and create a configuration to where you're going to add those type of radiuses and things in after you're done with that. But you don't have to. If it's just a visual thing and your shop knows that, you're just going to do that and you're going to use that machinery, that's how you manipulate the flat pattern. But it's important to understand what we talked about the peanut butter sandwich. When you're doing these type of things to the flat pattern, they're not going to reflect back to the model. There's going to be some times, and it's coming up at the end of this when I get to my last step, to where we're going to want to manipulate the flat pattern, but we're going to want that information to show in the 3D view so that my operator knows, hey, there's a function here that I've added that you need to see. And then that's when the peanut butter needs to be between the two slices of bread. So I don't know about you all, but I'm getting hungry right now just talking about it. So now that we've done that, we're still going the flat pattern. We're going to go to step 9. And this is cutting corners. I try to do this daily in my workflow. Any corner that I can cut, I try to do that. And we're going to use the corner trim to do this. Now, the reason that we're doing this is I'm going to create my base flange. I'm going to put some edge flanges on that, going to go through some of the other steps that I've talked about. But the reason that I'm going to be using this corner trim is I've got an NC programmer, and for whatever reason, in my workflow, I'm using tear on my sheet metal part. And I may have some corners in there to where they're not tearing nice, they're not playing nice. And we've all seen it in the SolidWorks where you get the flat pattern and it's, the lines aren't exactly right. It's not exactly what you want it to do. So one of the things that one of my NC programmers asked me to do is, can you go in there and add a relief? And basically in that relief, all that I'm going to do is I'm going to add just a very small, tiny round in those corners. And corner trim is what allows you to do it. If you're not in the flat pattern, like I was showing you earlier, you can't use corner trim. If you're in the flat pattern, you can now come in here and you can either pick, if you're having one instance in a corner giving you a problem, you can pick that. You can use squares, you can use rounds, whatever you need to do, however your workflow or your shop is running to get that relief in there. This is where you do it. So if you're consistently having flat patterns to where your corners are coming up to where they're just not looking right, you don't want to go back and redo your sheet metal part to where you're going to work through all of that. You're just going to give them some nice corners to kind of cover up what the flat pattern's doing in the background. This is where you would do that. Now, getting back to our peanut butter sandwich, that was done outside of the two pieces of bread, and the pieces of bread being your features and your flat pattern. So you're not going to see that in your 3D model view. So now we want to show it in our 3D model view. And this is one of the things with SolidWorks, when I'm working with sheet metal, that I had to learn early on. SolidWorks does not necessarily cut across bend. And what I'm meaning by that is if you're applying something that's going to go, there is instances that it's better now than it used to be. But one of the things that we use here on a daily basis is we use hand bends. So we're going to roll into step 10 here, Cody, and we're going to keep it flat. Today, I want to walk you through something I've been using inside of SolidWorks, a process I recommend adding to your daily workflow. It is one of those design tricks that looks simple, but it combines several powerful sheet metal features to create a clean, realistic part you could actually fabricate in the shop. I start off with a 200mm square sketch. It's always good to keep things simple and straightforward at the beginning. No unnecessary lines, just a clean profile to build from. From there, I create a base flange, 1.2mm thick. This sets up our sheet metal foundation, the main surface everything else connects to. Next up, I add the edge flanges, all the way around, each one 25mm long. This starts to form that familiar box-like shape, and it really helps visualize where the bends will occur later on. When you can see these edges forming, you start to understand how the flat pattern will unfold and refold later. Now is the fun part, adding an internal bend to create a hand bend area. To do that, I sketch a rectangle, 60 by 100mm, and I cut it right out of the main face. This clears out the section where the hand bend will sit. It's always worth double checking your cut alignment here. It makes the downstream features much easier to manage. After removing that center material, I use the edge flange tool again, this time bending that new edge outward with another 25mm flange. Now this step does two things. It creates the bend we need, and it helps to find how the finished part will behave when folded. If you're working with real sheet metal, you know how important that accuracy is. Every millimeter matters when you're folding real material. Here is where the real precision starts. I unfold that part to work directly on the flat pattern. This is something I recommend for anyone doing sheet metal modeling. Working flat gives you total control over your sketches and makes it easier to line up cuts exactly along bend lines. You can also measure distances more clearly and double check symmetry before refolding. Once that part was flat, I create a few reference lines to guide my cuts. My cuts are going to be 1.6 millimeters by 25 millimeters long. I make sure that everything is centered right along that bend line. I spend some extra time here zooming in and checking my spacing and making sure that the cuts don't interfere with the bend radius. For a hand bend, I'm going to need multiple spacings of that 1.6 by 25 rectangle. I'm going to use a linear sketch pattern. Now I'm going to go to the sketch tab and I'm going to select that. Then I'm going to select the rectangle that I want. I'm going to choose the direction I need and I'm going to enter the spacing on my sketch, and I'm going to get the 3 that I need, and I'm going to make sure that they're spaced 5 millimeters between each other. Now after I'm done with this, I'm ready to go on to my next step. After a quick check, I use the cut command to remove that material cleanly. Then I fold everything back up. And this is the moment that really shows how SolidWorks handles sheet metal properly. The bend shows up just as it would in real life because it's not a fake flattening. It's a true sheet metal feature that stays parametric. That means if you change the dimension later, the flange length, the bend angle, and even the thickness, everything updates cleanly. When the design is finished, I export a DXF from the flat pattern and give the part a proper name. During export, I made sure to include the necessary options: sheet metal information, bend lines, geometry, library features, and forming tools. That ensures that the file can go straight to the laser or punch without extra cleanup. And that's the whole process, a clean, efficient way to design a part that's both functional and ready to fabricate. I love this kind of workflow because it bridges the gap between design intent and real-world production. So those are the 10 steps. I probably went a little bit longer than 10 minutes, but I had to explain it. But those are the 10 steps. Let's just do a recap. We learned that the core of the 10 steps is you got to have a base flange to start with. You're going to use the edge flange when you're building your part, and you're going to go back and you're going to do things where the edge flange is going to have friends, whether that's, whether you're hemming it, whether you're doing jogs. You can even add sketch bends into this process. But all of those things are what you're going to need to become the expert in sheet metal that I know you can be. Thank you so much for joining us today. I hope that you can add some of these things into your workflow. And if you have any questions, please reach out in the comments and let me know. But that's our 10 commands in 10 minutes. I hope that you can add these to your workflow, and I hope it makes your life working in sheet metal better. Thank you, and I hope you have a great week designing.